Fractions 101. So this may be repetitive for some of you, but it's pretty important information and always good to be able to go back to it. So the first thing is you're going to want to know what a couple key words mean. The first is numerator. Numerator is the top number in your fraction. So the numerator is the top number. The denominator, on the other hand, is the bottom number of your fraction. So you've got the numerator on top, the denominator on bottom. Okay, and again, numerator is on top, denominator is on the bottom. So there's the D, stands for down. So remember that. Numerator on top, denominator on the bottom. What do each of them stand for in the fraction? So the numerator and the denominator have very specific meanings other than meaning the top and the bottom number in a fraction. And I would say we should probably start with what the denominator means, because this is probably the most important number in understanding how fractions work. Okay, because the denominator also has to do with the whole, and a whole is your whole shape, your whole region, or in some cases, especially when you're using number lines, your whole distance. But your whole shape, your whole region, or your whole distance. Now, the reason why I say that the denominator is one of the most important numbers here is because the denominator actually tells you how many parts are in the whole. How many parts are in your whole? So in a shape could be how many parts you're cutting it into. Same thing with a region. Distance could be how many jumps or skips or lengths that you have in the distance. Same thing with measurement, which is very similar to distance, and we would also use a number line for that, which we will discuss. Now, the numerator is how many parts are what we call represented. How many parts are represented? Now, usually when you see this, that means how many parts are shaded. It could be how many parts are taken away. But it's how many parts are represented. So when you look at a fraction, like when we did our example above of 1/2, that would be 1 out of 2 parts. So 1 part represented out of 2, or 1/2. So half of your whole number. So there's a relationship between all those. So as you know, I like to use pizzas as examples often for fractions. So let's say we take one and we cut it into 4 parts. 4 parts. So that would mean each one of these parts is 1/4 of the whole. Well, in this case, we know for sure, because we have 4 parts, that 4 is our denominator. So we're going to go ahead and put that down there. Now I'm going to shade 1 in. I'm going to represent 1 part out of the whole. And in this case, the whole again is 4. We've got 4 of them. So our denominator is 4, our numerator is 1. And so we have 1/4, which means every single one of the parts, including the shaded one, is 1/4. And 1/4 plus 1/4 plus 1/4 plus 1/4 is 4/4, which equals 1 whole. So 4/4 equals 1 whole, because you are representing 4 out of 4 parts. 4 out of 4 parts. And that means you've gotten the entire whole. That'd be like if I gave you the entire pizza and said, hey, you can have all 4 parts of this pizza. I just gave you 4 out of 4. So 4 over 4, 4/4 equals 1 whole. Now this goes for any type of fraction, okay? It would be the same if I said 100 out of 100. It would still be 1 whole. If you have your numerator and denominator the same, if you see those are the same, that means you have 1 whole. And that's really important to remember. Now let's draw out what we would call a fraction bar. This is a fraction bar, and we'll label it with 1 because it is 1 whole. That is 1 whole fraction bar. So the next one we draw will be the exact same. We're looking at the same whole, same size, same length, but this time we're going to divide it into 3 parts. We're cutting it into 3 parts. Now we know, because we have 3 parts there, 1, 2, 3, that our denominator will be 3. And each part will be 1/3. Each part is 1/3. So if we were to write out the entire thing, again, 1/3 plus 1/3 plus 1/3 would equal 3/3, which equals 1 whole. And you can see that because it matches up with the one whole above it. They look the same. And of course, if I was to shade in one of those, then I would be asking you, well, which part is represented? And you would say, well, you've shaded in one, so it's one whole. Excuse me, so it's 1/3. So again, remember, the denominator stands for how many parts are in the whole. That's why we have the 3 on the bottom, because in the case of the fraction bar, we have 3 parts in our whole. The numerator would be how many parts are represented. And again, usually that's shaded, or it could be taken away. It could be taken away. And in this case down here, we just labeled all 3 parts. But let's say that we drew out another pizza, and then I said, okay, well, we're going to go ahead and show you what it looks like if one is taken away. So let's go ahead and draw that out again so that we have a missing part. So with our missing part right there, that would be the same thing. If you see a word problem that says how many parts, or any type of problem, doesn't have to be a word problem, but sometimes those can get a little confusing. How many parts are represented? You would say 1/4, because we've cut the pizza into 4 and one piece is missing. 1/4 of the pizza is missing, which means I've eaten that one and I left you 3/4, which is really a better deal. But it's always good to remember that. So no matter how you look at it, your numerator will be the part that's shaded or the part that's missing, whatever it is. Now, some of you may be familiar with cooking. This is a cup here, like you might see in a kitchen if you need to help a parent or a grandparent or a guardian get something, like a cup of sugar, for instance. You might see this, but this is why fractions apply all over the place, all different parts of your life, because you're going to see them everywhere. That was just an example in cooking. I like to use food a lot, of course, for my examples, but this is why it's really important to remember them. Now, I mentioned a number line, and these can be used, of course, for distances. They also look very similar to a ruler when you're doing length. So in this case, we have a number line with a 0 on the left-hand side, 1 on the right. 1 equals the whole distance. The whole distance. Now we're going to make some marks on it to indicate what we might call jumps or lengths. Now, ideally, these would be, I would have drawn this out better, and they would be equal, because we're trying to look for equal lengths. So pretend that those are equal, and these are jumps across the top, jumps or skips or lengths. Often you'll see them called lengths. Sometimes we call them jumps just because that's what it looks like, and it kind of looks like skip counting, right? And in this case, there are 3 of them. So you're not going to count the lines. Don't count the 0, 1, 2, 3, and then the line at the end there. Count just the lines in the middle. You have 1/3, 2/3, and then of course the whole, as we mentioned above, is 3/3. Now you'll notice that this number line looks a lot like that fraction bar. It looks a lot like it, and it should, because they can be, and you can use them. This is what I always say in class: when in doubt, draw it out. If you're confused about a fraction, or you're unsure about what a question is asking you, and it's asking you to draw out a problem, of course, do it. Draw it out. When in doubt, draw it out. Draw out a number line, a fraction bar. You could even do it with arrays. Draw out a model. Draw out a pizza, like I like to do. Anything that will help you be able to divide it up and look at it visually. And oftentimes you will want to rely on your eyes to see if something looks like it's equal, or to see what's missing, what's represented, what the numerator is, what the denominator is, that type of thing. Okay? Well, I'll be back soon with another video. If you have any questions in the meantime, just let me know.